Hello students. So in my previous video I discussed the first 10 questions which were taken from the Pearson Edexcel AS level exam, and the topic was formulae, equations, amounts of substances. In short, it can also be considered as to be dealing with the moles and stoichiometry and the equations. So in this video, I will be solving the next 10 questions, that is from 11th onwards. So I will be giving the detailed solution of each and every multiple choice question, so that you will understand how that particular answer which is given in the answer key is obtained. So we go to the first question, that is the question number 11. How many moles of atoms are present in 240 centimeter cube of carbon dioxide at room temperature and pressure? 1 mole of any gas occupies 24 dm cube at room temperature and pressure. All right. So the key point to understand in this question is that they are asking about the moles of atoms, not the moles of molecules. So you have to understand that 1 mole of carbon dioxide in fact contains 3 moles of atoms, that is 1 mole of carbon and 2 moles of oxygen. So once you get the number of moles of carbon dioxide, which is the 240 centimeter cube, which if you convert to dm cube, it will be 0.24 divided by 24, that is your 0.01 moles. But then you have to multiply that by 3 and you get 0.03 mole of atoms. So that's the answer of this question. The answer is D. Okay, let's go on to the next question. What is the percentage by mass of nitrogen in ammonium nitrate? So you need to know the molar mass of ammonium nitrate. So I have written this as N2H4O3, which helps you to get the molar mass. So if you just add all the atomic masses given over here, you get 80, which is the molar mass of ammonium nitrate. And then in this molar mass you have 2 moles of nitrogen, and since the molar mass of nitrogen is 14, 2 moles means it becomes 28. So 28 over 80 into 100, which gives you 35%, that is the mass percentage of nitrogen in ammonium nitrate. So the answer is D. Let's go on to the next question. A compound of nitrogen and hydrogen only is analyzed and found to contain 97.7% by mass of nitrogen. What's the empirical formula of the compound? And these are the options. A student may be tempted to write the answer as ammonia because ammonia is the most common, but let us see whether that is the answer. So the percentage of nitrogen is 97.7, so hydrogen will be 100 minus 97.7, that will be 2.3. Find the moles of nitrogen, that is 97.7 divided by 14, this gives me 7 moles, and 2.3 divided by 1 gives me 2.3, which is roughly in the ratio of 3:1. So this 3 represents nitrogen and 1 represents hydrogen, so the formula is N3H, which is D, and not what we suspected, NH3. That's not the answer. The answer is N3H. Okay, so let's go to the next question. Which of the following can be determined for an unknown alkene using only percentage composition? Is it the molecular formula, the empirical formula, both molecular and empirical, and the structure? Now, to get the molecular formula, you also need to know the molar mass. But the molar mass is not given, therefore it will not be possible to calculate the molecular formula. We can only know the empirical formula. Structural formula also cannot be decided by the percentage composition. Okay, so the answer is B. Let's go to the next question. That is 1.12 gram of iron reacts with oxygen to give you 1.6 gram of an oxide of iron using the relative atomic masses. What is the formula of this oxide? This is more of a straightforward question, that 1.12 gram of iron, so divided by 56 gives you the number moles of Fe. The amount of oxygen will be 1.60 minus 1.12, that is 0.48, divided by 16 will give you the moles of oxygen. So this is obviously in the ratio of 2:3. So the formula is Fe2O3, and that's the answer D. Let's go to the next question, that is question number 16, and it says here that in an experiment 1.226 gram of potassium chlorate 5 was heated, a mass of 0.320 gram of oxygen was collected. Use the molar mass and relative atomic mass of oxygen and the percentage yield of oxygen in this experiment. Okay, so more or less a straightforward question. First we will calculate the number of moles of KClO3, which is 1.226, and divided by 122.6, that is giving you the number of moles of KClO3, which is 0.01. So what will be the moles of oxygen? See, it is in the ratio of 2:3. That means for 2 moles it is 3 moles. That means there is more of oxygen. So we have to take the ratio as 3:2, because that is more than 2. If you do 2 by 3, it will become less. So it is obviously more, the oxygen is more, so 3 by 2 is more than 2. So that way you can understand that whether it will be 3 by 2 or 2 by 3. So 3 by 2 into this 0.01, that gives me obviously the number of moles of oxygen, which is 0.015. Now that is 0.015. So the number of moles of oxygen is so this will be in fact this value is incorrect over here, so it will be 0.015 multiplied by 32, that is 0.48 gram, and so the expected yield is 0.48, but we got only 0.32. So the percentage yield is 0.32 over 0.48 into 100, which is 66.7%, and the answer is C. Okay, so we go on to the next question, 17. Oxygen can be converted into ozone by passing it through an electric discharge. So this is the reaction. 3O2 gives you 2O3. In an experiment, a volume of 300 centimeter cube of oxygen was used, but only 10% of the oxygen was converted into ozone. All volumes were measured at the same temperature and pressure. The total volume of gas present at the end of the experiment. Okay, so how do you go about this question? First, you have to consider this volume 300 centimeter cube, and only 10% of that is converted into ozone. So what is the 10% of 300? That is 30 centimeter cube. That means only 30 centimeter cube of oxygen is converted to ozone. That means out of 300, only 30 centimeter cube is converted. So 300 minus 30, that is 270 centimeter cube of oxygen is still remaining unused. Now what will happen to 30 centimeter cube of oxygen that is converted into ozone? Since it is in the ratio of 3:2, you will get only 20 centimeter cube of ozone. So the total volume is 20 centimeter cube of ozone plus the 270 centimeter cube of oxygen that was unused. Therefore the total volume is 290 centimeter cube, and therefore the answer is C. Hope you understood this. Okay, now this was a tricky question. 1.40 gram of an alkene gave 3.77 gram of a dichloroalkane on reaction with chlorine. What is the molecular formula of the alkene? Oh, obviously the first step that you can always take is that you can find out the mass of the chlorine, because 3.77 minus 1.40 will give you the mass of the chlorine. Then you can also find out the moles of chlorine by dividing by 71, that is 0.0334. But the problem arises that how do you decide that what is the moles of the alkene? Because to get the moles of the alkene, you need its molar mass, but that is what is actually being asked. So you have to actually go back and understand this reaction, that then an alkene and chlorine will give you dichloroalkane, and alkene and chlorine react in the mole ratio of 1:1. In other words, the moles of the chlorine will be equal to the moles of the alkene. That is how you get the moles of the alkene. So, and then if you divide the mass of the alkene by its number of moles, you will get the molar mass, which is approximately 42. And the molecular formula C3H6, that is 36 plus 6, corresponds to 42. Therefore, the answer will be P. So that was a difficult question, because how to know the moles of alkene, that was the problem. Okay, so the 19th question, the recommended limit for safe exposure to sulfur dioxide is 0.000025%. What is the concentration in parts per million? So percent means over 100, 10 raised to 2, and you have to find for million, that is 10 raised to 6. Simply solve it, you get 0.25, and that's answer is P. Okay, what is the number of atoms in 2.8? So here again there is a trick, a smart question that they ask in the atoms. So you have to think that in 1 mole of C2H4 there are how many atoms. So you can see that there are 6 moles of atoms in 1 mole. So that you have to think. So after calculating the number of moles of C2H4 by dividing its molar mass, you get 0.1, but the number of atoms will be 6 times of that. So multiplied by 6, and then you multiply by the Avogadro number. So this is the answer you get, and that is the answer D. So I wanted to solve only these 10 questions to make a short video. Hope you understood the methods of mole concepts and the stoichiometry, and keep watching, and I'll be uploading some more videos on moles and equations, stoichiometry, which will help you to understand the subject. Thanks a lot for watching, and you may subscribe to the channel and give your honest comments. Thanks a lot.